the Kepler Telescope Exoplanet Discovery Data Analysis Project. So the planet that I did my information on is K2 286b, which is a new potentially habitable planet. And here's the key on the right. Green markings signify the given equation. Red signifies the known number, obviously not the K2 286b part, but later in the project it will. Blue is for clarification, and this teal color is for the answer. So we start out with M1 on the left and M2 on the right, M1 being the star that K2 286b orbits, and they both emit the same force on each other. As you can see, F1 equals F2. So now we're going to calculate the gravitational force between both of them. So F1 equals F2, so the F1 in this equation can equal both of them. Then it equals G, which is the universal constant for gravity, which is, as you can see, lower, 6.67 times 10 to the negative 11th newtons per mass divided by kilograms squared. And r squared is the center to center distance, and I did a little diagram for clarification right there. It's like the radius plus the distance between the two planets. So that's the equation right up there. Now, what is known is the radius of our planet that is given, and the mass, which I also had to derive from the website's equation, and the density was nothing, which doesn't really matter here. I do not know why I wrote it. And then the mass of the star, which we will be using in the equation, is 1.989 times 10 to the 30th kilograms. Then the distance between them is, as you can see right there, and I had to convert that from, I think it's, oh gosh, I know this. It's like atomic universes or something. I can't remember. Atmospheric units, I think it might be. And I transferred that number, which is distance like measurement, into kilometers, and it is 2.64 times 10 to the 7th kilometer. And that's both of the radii plus the distance between the two planets. And I plugged that all into the equation shown above, which is F1 equals G times M1 times M2 all over R squared. As you can see, I squared the R, and I put the G, which is universal, plus M1 and times M1 times M2, and I got the answer of F1 equals F2 equals 5.749 times 10 to the 30th newtons. Now, down here, I have another equation, and this one is trying to derive the velocity. I don't know why I wrote velocity time, it's just velocity, but yeah, I'm deriving the velocity it takes, the planet K2 286b has to take around the central star, which is not the sun actually. It's just a central star. So, to derive this velocity, you need to have the circumference and the time it takes to do a full revolution. So, we don't actually have the circumference, but we do have a given radius, which is up here. I think we got it. 2.64 times 10 to the 7th. Or that's like the distance, if you know what I mean. So we're actually doing the circumference of the whole entire thing. So yeah, 2.64 times 10 to the 7th kilometer. Then we have the circumference equation right here on the right. C equals 2 times pi times r. So as you can see down here, I wrote 2 times pi times the given radius that I found. And their circumference ends up being, it's a large number. It's 1,657,000,000, 165,657,000 792,000,000 and 1,000 kilometers. And I multiplied that by 1,000 because it has to be in meters, because we're doing this meters per second. Oh, and also up here, the orbital period given on the website was 27.4 days, which is 2,367,360 seconds. So I got the seconds up there, and I just needed to get the meters. That's why I was doing the circumference. So I did kilometers times 1,000. Let's go back to that. And I got 1.66 times 10 to the 11th meters. Now, since I have the meters and the seconds, I just divided the seconds from the meters, and I ended up getting a velocity of 70,032.4 meters per second. That is all of the equations I can do from this given information. Now here are the works cited. As you can see, I used the NASA given information, and it was a little bit confusing, but I worked through it. And the exoplanets.nasa.gov one, that one gave me a lot more clear information, which I appreciated. And then this YouTube link is from Bozeman Science. He gave me the equation to derive the force between the two planets. Now, here are some extra facts down here. This system only includes K2286b and its star. That's why I only included them in the equation and not more than one planet or more than one moon, because there's no moon on this planet. This was found by Diaz Alonso in 2018, so it's a relatively new discovered planet, and it's about 3,600 degrees Celsius, which is not the most habitable, but we can make it work because it has the correct resources for us. And the surface gravity is 4.7 plus or minus 0.2 log 10 centimeters per second squared. I wasn't sure how that rounded to Earth's, because Earth's surface gravity is 9.8, so I wasn't sure how that really correlated, but yeah. So thank you so much for listening to this project, and I hope you enjoyed it.